Assalamualaikum and hi, my name is Mohammad Iqbal Afiq bin Mohammad. My metric number is AE1944. I'm from group 6 and our title is Magnetostatic Speaker.
Assalamualaikum warahmatullahi wabarakatuh. My name is Saifuddin bin Hairuddin, AE190005.
Hello, my name is Antonio Orlando and
Hello, my name is Mohammad Zaim Marwan bin Mazlan and my metric number is AE190070.
Hello, my name is Antonio Orlando and today I'm gonna present introduction for our project topic. Okay. Speaker are compound of a cone attached to an electromagnet and a permanent magnet. Variation in electric charge induces charge in the electromagnetic field at the electromagnet and move the cone relative to the permanent magnet and producing a sound wave. Other than that, speaker are transducer that convert electromagnetic wave into a sound wave. The speaker receives a audio input from a device such as computer or an audio receiver. That's a key factor in a function of a speaker. And the topic of discussion for this project or poster is that the permanent magnet need to produce a strong, consistent magnetic fields to interact with the variable fields of electromagnet. The most common permanent magnet among the speaker is an alloy mixed with a metal that is more stable and resistant to the corrosion that constituent metals. This magnetic moment of the individual atom can combine parallel to each other among the large group of atoms to form a magnetic domain. This domain contains very many atoms which all contribute to make a strong magnetic force which will remain even in the absence of applied magnetic fields. This property known as ferromagnetism. The sound produced by the speaker is definitely a frequency and amplitude. The frequency determines how high or low the pitch of sound, and for the example, soprano singers sing a voice produce a high frequency range. That is an example of the high frequency, and a speaker system ability to accurately produce sound frequencies in a good indicator of how clear the audio will be and the most stable of the magnetic fields. I think that's all for the introduction.
Okay, next we continue to working principle. For working principle, a magnetostatic loudspeaker is a dipole loudspeaker that is similar to an electrostatic loudspeaker, but instead of using high voltage and uses high current. Permanent magnet provide a static magnetic field. Wires or strip carrying audio frequency currents are bonded to a thin diaphragm. The current flowing in the conductor interacts with the magnetic field and creates sound in much the same way as in a conventional dynamic driver. Because of its dipole structure, this kind of speaker creates sound mostly to its front and back. The impedance of magnetostatic speaker is often mainly resistive, but in some cases may be so low that amplifiers have to be ready to fit low impedance. Magnetostatic speaker provide good sound quality and may be very thin, but their height and width dimension are large. So here is the picture of working principle of magnetostatic loudspeaker. So next we continue to permanent magnet. For the permanent magnet are those which create their own persistent magnetic field when magnetized by external magnetic field. The function of permanent magnet in loudspeaker is to convert electrical energy to mechanical energy. The permanent magnet in loudspeaker is fixed close to a mobile electromagnet coil. The electromagnet is attached to a flexible material called cone diaphragm. Passing an electric current in electromagnet causes it to vibrate due to the interaction with the permanent magnet. The cone amplifies this vibration to produce sound wave. The frequency of vibration control the pitch of the sound, while amplitude controls the volume produced. Microphones use the same set as loudspeaker in reverse mechanism to convert sound wave to electrical signal. So the mechanism of microphone and loudspeaker are the same, but for microphone, the mechanism of the permanent magnet will be reversed. So here is the picture of permanent magnet inside the loudspeaker.
Okay, for next, magnetostatic, they are mentioned in the working principle. Okay, static magnetic field. Maxwell equation predict the static magnetic field are produced by moving charge or current. There are no magnetic charge and therefore no source and seek for magnetic lines. Static magnetic field lines always form a closed loop, and the encircle moving charge according to the right hand rules. In this figure, an isolated charge magnetic monopoles does not exist, thus the total flux through the surface is zero. This is a Gauss law for magnetism, non-existent of the magnetic poles. Okay, next, the magnetic force on the short circuit of the pole, two wire lines as they mentioned in the working principle. Two parallel current carrying wires and can either attract or repel each other depending on the magnetic force on the segment AA of the two wire short. If a large current surge occurs in the line, it's a current in the formula, so the fault short circuit can be quite large because the current is the position at the above, so that the track. And for example, if there is sudden increase of current intensity to current 5000 ampere, A 0.5 cm and D 450 cm, the fault short is about 23 Newton, which may be sufficient to open the short circuit if it's not firmly connected. The next electromagnet in the speaker also have electromagnet are magnet which produce their magnetic field using electric current, and then when the electric current is allowed to flow through the wire, a magnetic force is produced. Then when there is no current, there is no magnetic field produced. So how the speaker work? So from the microphone to the speaker, an electric signal passes to the wire coil, and then the permanent current to the wire coil and diagram. So the current flowing through the coil generated magnetic field around it. It explains the force the permanent magnet making it move. The current change the size and direction which make the magnetic field around the coil change. So change the movement. So the diagram will move with the coil passing the vibraton to the surrounding air which has the sound.
Okay, now I will present the methodology part. First is the principle of magnetostatic speaker. Speakers are transducer of energy that convert electrical energy, audio signal, into mechanical wave energy. Many speaker drivers utilize electromagnetism to turn the AC voltage of the audio signal into their graph movement within a magnetic field in order to produce sound. The back and forth motion of electromagnet is controlled entirely by electric current applied to the electromagnet. So more current will increase the electromagnetic force applied to electromagnet, will deform the cone more and produce more sound. Okay, next part is magnet in moving coil. As we can see, the electrical audio signal is fed to the voice coil, a conductor wire winding around a cylindrical former. The voice coil is immersed in the air cap and a small cylindrical space where a strong magnetic field is generated by a permanent magnet. So there is the electrical current interact with the field to generate a Lorentz force acting along the coil axis. Okay, next part is the magnet in magnetostatic. As we can see, there are magnet array to either side of movable diagram. The magnetic field strength is concentrated at the diagram. And this diagram has printed embedded conductive wire that cover its area in a serpentine fashion as the AC voltage audio signal pass through the conductive element of the diagram. A varying magnetic field is produced in or around the diagram. This varying magnetic field is interact with the permanent field of the magnetic array and cause the diagram to move and produce a sound in accordance with the waveform of the applied audio signal. So for the last point is magnet a magnetostatic speaker. Magnetostriction is a property of ferromagnetic material that causes them to change their shape during the process of magnetization. The sound of magnetostration can be heard as the dreaded 60 cycle hum or 50 cycle hum depending on where you live. That you hear from power mains transformer. So as the audio signal is passed through the stationary coil, a varying magnetic field is extended to the magnetostriction core. As the plate experience a varying magnetic field, they change shape ever so slightly in a shape and move a diagram to propagate sound wave. When the coil is not experiencing an audio signal, the coil and its magnet return to their original shape, as we can see here. So that's all for me.
Okay, for next methodology, a magnet in magnetostatic speaker. Magnetostation is a property of the ferromagnetic material that causes them to change their shape during the process of the magnetization. The sound of magnetostation can be heard as the dreaded 60 cycle hum or the 50 cycle hum depending on where you live. That you will hear from the power manual transformer. So as the audio signal is passed through the stationary coil, a varying magnetic field is extended to the magnetoscore. And as the experience of the magnetic field, they change shape ever slightly in shape, a move of the diagram that propagated a sound wave. When the coil is not experiencing an audio signal, the coil and the magnet return to their original shape. So this is a diagram of that.
And now for the conclusion is speaker produces sound by interaction of permanent magnet and electromagnet. Neodymium magnet is commonly used in permanent magnet is speaker because it is a high magnetized and demagnetized and a small size. As in this speaker don't amplify the audio signal and they record high level of audio input which may be produced by a audio speaker. That's all from me. Thank you.